Hi guys, my name is Donald Caracuel from STEM 11.
I'm Lizette Andrea Condition.
Joshua Adrian E. Custodio.
Christian Omar M. Regidor.
Marco Paulo ang bata.
Jonathan Aaron M. Cortez.
On this video, we are going to teach you how to solve limits of a function together with my group mates.
The limit of 6x minus 2 as x approaches to 4. On finding the limits of this function, the first thing we always need to do is to direct substitute the value of x, which is 4. 6 times the value of x, which is 4, minus 2. Let's perform the indicated operation. 6 times 4, 24. Minus 2 equals 22. In this case, the limits of 6x minus 2 as x approaches to 4 is equals to 22. Take note, not all the time we can get the limits of a function just by direct substitution. It just happened that this example is simple and we can get the limits by direct substitution.
This example, the limits of x minus 2 over squared minus 4 as x approaches 2. First, we will do a direct substitution of x. 2 minus 2 over 2 squared minus 4, it is equals to 0 over 0. When the answer is like this, it will be called indeterminate form. From here, we have to use whether rationalization or factorization. But as you can see, in our function, we can factor out the denominator, which is like this: x minus 2 over x minus 2 x plus 2. This is the factor of x, where minus 4. In this case, we can cancel out x minus 2. And this will become 1 over x. That's 2. Now, we can substitute the value of x1 over 2 plus 2 equals 1 over 4. So in this case, the limits of x minus 2 over x squared as x approaches 2 is equals to 1 over 4.
So in example number 3, which is read as the limit of square root of x minus 3 over x minus 9 as x approaches to 9 is, the first thing that we're going to do is we direct substitution x with 9. So as we direct substitution it, the answer will become 0, which or also known as indeterminate form. So, but as we can see, there is a square root in the numerator in the numerator above x, which is the radicand in the numerator of the function. So what we're going to do is we rationalize it. So what's gonna happen is we're going to rewrite the example, which is the square root of x minus 3 over x minus 9 times the square root of x plus 3 over the square root of x plus 3. The reason why it became like this, it's because this is how we rationalize. We are multiplying a function to the opposite of its numerator. So, as we simplify it, it will be x minus 9 over x minus 9 times the square root of x plus 3. And so, we cancel minus 9 of the numerator and the minus 9 of the denominator, which will become 1 over the square root of x plus 3. Then, we're going to substitute the square root of x with the square root of 9 because that was in the example. And when we're going to solve it, the answer is going to be 1 over 6.
How about this one? The limits of 5x cubed plus 3x squared plus 1 over 4x squared plus 4 minus 7x cubed as x approaches infinity. Just like the other, we do direct substitution. And since the x approaches infinity, it will goes infinity over infinity. Every time the x approaches infinity, this will always the answer in direct substitution. And this is considered as indeterminate. Why? Because we don't know what will dominate. So, we have to use the rules wherein since the condition is inconstant, we are going to divide each term to the highest degree. So, 5x cubed plus 3x squared plus 1 divided by the highest degree, which is x cubed. So, x cubed over 4x squared plus 4 minus 7x cubed. We are also going to divide to the highest degree, which is x cubed. So, cancel, and this will become 5. On the denominator, we are also going to cancel this, and this, and it will become 7. So, the limits of the given are 5x cubed plus 3x squared plus 1 over 4x squared plus 4 minus 7x cubed as x approaches infinity is equals to 5 over 7.
Example number 5. The limit of x squared plus 2x minus 15 all over x squared minus 9 as x approaches to 3. Again, let us try to direct substitute the value of x, which is 3 squared plus 2 times 3 minus 15 all over 3 squared minus 9. Simplifying it, we can get 15 minus 15 all over 9 minus 9 equals 0 over 0. And we know that 0 over 0 is indeterminate form, meaning we should rationalize or factor out the function. And as you can see, both the numerator and denominator can be factored out. So, it will goes like this. the factor of x squared plus 2x minus 15 is x plus 5 times x minus 3 all over the factor of x squared minus 9, which is x plus 3 all over x times x minus 3. As you will notice, we can cancel out x minus 3 to x minus 3. And we will have x plus 5 all over x plus 3. This time, we can now substitute the value of x, which is 3. So, 3 plus 5 over 3 plus 3 is equals to 8 over 6 or 4 over 3. So, the limits of x squared plus 2x minus 15 all over x squared minus 9 as x approaches to 3 is equal to 4 over 3. That is our final answer.
And for our last example, the limit of square root of x minus 4 all over x minus 16 as x approaches 16. Let us direct substitute the value of x. Square root of 16 minus 4 over 16 minus 16. Simplifying it, we can get 0 over 0. And we know that 0 over 0 is indeterminate form. So we have to choose whether rationalization or factorization. Since we have radicand, it means we should rationalize it. So square root of x minus 4 all over x minus 16 times the opposite of this numerator, which is square root of x plus 4 all over square root of x plus 4. Multiplying it, we can get x minus 16 over x minus 16 times square root of x plus 4. Now we can simplify x minus 16 to x minus 16, and we can get 1 over square root of x plus 4. This time we can simplify the value of x, which is 16. Let's substitute it. 1 over square root of 16 plus 4 or 1 over 8. So the limits of square root of x minus 4 all over x minus 16 as x approaches 16 is equal to 1 over 8. This is our final answer.